First of all, I would like to acknowledge my co-author, Dr. Patrick Landine. He's the Chief Geoenvironmental Engineer with Cameco Corporation. I believe he's in the audience, and he may have some questions that he might be able to answer that I might not. We have some experiences from uranium tailings that I believe may have some relevance to the Directive 74, part of the oil sand tailings. Now, my understanding is that the objectives of the ERCB Directive 74 are, first, to reduce long-term storage of fluid tailings by fines capture in designated disposal areas. Two, tailings in DEDAs must achieve an undrained strength of 5 kPa within 1 year of deposition. And the third objective is that the DEDAs must be ready for reclamation within 5 years after active deposition has ceased, with a trafficable surface having an SU or undrained strength of 10 kPa. Now, we do not actually have much experience with this first objective here. In fact, the preferred method of disposal of uranium tailings now is actually subaqueously. So we actually create pretty well a fluid footprint. However, the amount of uranium tailings is quite small compared to oil sand tailings, so it's probably not a big issue. In fact, has now become a big issue so far. Now, we do have some experience with this objective here that we'd like to share with you today. Our experience is somewhat negative with this, but I think there's still some valuable lessons that could be learned from it. The objective number 3, we in fact are able to meet this objective with the current practice. We can ready a deposit within 5 years after active deposition has ceased for decommissioning. However, we do not actually achieve this last part of the third objective. Now, this is a typical facility. The experience from Rabbit Lake Input TMF, our tailings management facility, is the one we're going to talk about today. It was first converted into a tailings management facility in 1984. This somewhat predates my involvement with the uranium tailings. In fact, it predates me by about seven years or so. In the design of this facility, tailings are placed within a pervious envelope. Now, this is the pervious drain that surrounds the tailings deposit. Now, this is done to minimize groundwater flow through the tailings after closure. A bottom drain, this bottom drain here, is provided and it's connected to a lateral drift, and again connected to a raised well and can provide pumping. So the bottom drain is actually pumped, totally pumped out of the system. It therefore helps facilitate consolidation of the tailings. The original design at Rabbit Lake included disposal of filtered tailings, and I believe this was done to minimize particle size segregation upon deposition. The filtered tailings were deposited subaerially from November to December 84, and again from November 85 to mid-June 1986. The tailings were filtered to about 50% solids and had an undrained strength of This is my estimate of about 2 to 3 kPa. Now this was never really a requirement in the disposal system used at Rabbit Lake. The filter cake was hauled and deposited by scrapers and spread by wide track dozers. The tailings disposal had to be changed over to pre-thickened tailings slurry discharge by a pipeline in June to 1986 due to trafficability problems on the filter tailings. And I think over here, that's the only relevant picture that I could find that shows a wide track dozer bogged down in the tailings. Now this is a photograph of the Rabbit Lake TMF. When slurry discharge has been deposited subaerially, there is the old filter building. The filter building was still used for thickening the tailings for the last 20 years since 1993, I believe. The filter building has not functioned. All the thickening of the slurry is done in the mill itself. Current practice has evolved from cumulative experiences from various tailings disposal facilities over the last 40 years. Detailed description is provided in a companion paper to this conference, Geotechnical Fundamentals of Uranium Tailings Management in Canada. Some highlights relating to the engineering of the tailings deposit itself are presented below. In this design, the actual engineering of the tailings deposit has quite an important role. There are two basic requirements from the tailings deposit. The pre-thickened slurry is to be deposited in a manner to create a homogeneous or an unsegregated tailings deposit. The tailings must be fully consolidated at closure to prevent expulsion of contaminated pore water after closure. This has led to subaqueous disposal to prevent frost buildup in the tailings deposits associated with the more conventional subaerial depositions in northern Saskatchewan. This facility, in fact, was changed over. This is again a picture of the Rabbit Lake in-pit tailings management facility in 2012. There's the old filter building still there. Now, this is the disposal now has been changed over to subaqueous deposition to prevent further frost buildup. For cover construction, the tailing surface is to be drained and allowed to desiccate for up to a period of 2 years. Cover is placed in stages, commencing in springtime when the tailing surface is still frozen. Now we have some experience from doing this construction in a similar environment on a slimes pond at the Rabbit Lake above ground tailings management facility. Here, what you see is a filter cloth has been installed on the drained surface of the tailing, the slimes pond, and a truck bringing the fill in. But if you notice, the truck is not allowed to travel on the filter cloth. In fact, it travels on the first layer of fill. Now, this is just another slide just showing dozers completing the first lift. In the current practice, the tailings deposit can be readied for cover construction within about 5 years after the end of active tailings deposition is completed. Now this, I believe, is essentially meets the ERCB Directive 74 requirement. I think we should take a moment here and review what I've been saying. We have experiences from the uranium tailings. We have 2 experiences that we have talked about here. We have some spreading problems with the filter tailings that forced the changeover to thickened slurry discharge. And we do have timely consolidation of the decommissioning is attributable to the hydraulic conductivity of the tailings deposit, the unsegregated tailings deposit, to be about 10 to the minus 7 to 10 to the minus 8 meters per second. Now this is the experience that we have from uranium tailings. What relevance does it have to the oil sand tailings and the Directive 74 is on this side. Now I believe with respect to the first experience here, we should expect the same kind of experience in the oil sand tailings. It would apply to the pre-treated oil sand tailings that would meet Directive 74. That is not to say that you would have to abandon that. I'm just saying some of the constraints would be the same, and you would have to consider those. Now, there are three fundamental factors in tailings disposal: the transportation of tailings, and then deposition and spreading of tailings, and then consolidation of tailings in place. Now, in terms of the filtered tailings, the problem that we experience here was the tailings are hauled by trucks, so the hauling was not a problem. It's actually during the spreading of the tailings that forced this changeover to occur. Now, similar sort of considerations would have to be given to whatever system you select to meet Directive 74. Now, the second positive experience that we have with the uranium tailings is that consolidation can be achieved in a timely manner for decommissioning to begin within about 5 years, and it's attributable to the permeability of the tailings, which is in the order of 10 to the minus 7 to 10 to the minus 8 meters per second. Now, I would think that you would expect similar sort of experience with the unsegregated oil sand tailings treated to meet minimized particle size segregation due to similar hydraulic conductivities. Now I believe that the correct term used in the oil sand tailings, I think, is the composite tailings. So I see that there'd be similarity or similar experience one would expect what we experience in the uranium tailings. If you're treating the oil sand MFT, it's pre-treated to meet D74 requirements without modification of K, would undergo large ongoing settlements after closure due to the lower K values, which are 2 orders of magnitude lower generally from what we have in the uranium tailings. Now, earlier today, there was a great deal of discussion on the potential for future settlements in the tailings deposits, and I think that's basically what we're saying here. Thank you very much.